Good morning, everyone. Myself, K. Niraimadi, Assistant Professor in the Department of Electrical and Electronics Engineering in Sri Muthukumaran Institute of Technology. Today, I am going to present a topic from the course WE3602 Power System Operation and Control. My presentation mainly focuses on Unit 1, Introduction with special emphasis on system load variation and low curves, which form the foundation of power system planning and operation. Objective courses. The objective of the courses are to understand the importance of power system operation and control, to study real power frequency control and reactive power voltage control, to learn economic operation and generation scheduling. Do get on introduction to SCADA and computer aided control. In today's presentation, we will mainly address the basic operational concepts related to load behavior. Units of Power System Operation and Control. These courses consist of 5 units. First unit, Introduction. Second unit, Real Power Frequency Control. Third unit, Reactive Power Voltage Control. Fourth unit, Economic Operation of Power System. Fifth unit, Computer Aided Control of Power System. Our focus today, Unit 1, which gives the basic understanding of how load varies and why regulation is needed. Unit 1, Introduction. In Unit 1, we study Indian power systems scenario, load dispatch centers, need for voltage and frequency regulation, real power versus frequency and reactive power versus voltage, system load variation and load curves, load forecasting, load scheduling, re-regulation and energy tariff basis. Among these system load variation is very important because generation must always match demand. System load variation. The system load variation means the variation of electrical load on a power station with respect to time. The load on power system never remain constant. It changes hour by hour, day by day, and season by season, depending on consumer usage. Types of system loads. The system load in an area depends on 5 major categories. First one, domestic or residential load, commercial load, industrial load, agriculture load, and other loads such as street lighting, traction, and municipal loads. Each type of load has different usage patterns, which causes variation in total system load. Causes of load variation. The load occurs due to social and religious events, weather conditions such as temperature, humidity, cloudiness, and wind velocity. For example, high temperature, the more air conditioner load. Festival loads means increased lighting and domestic usage. Hence, load variation is unavoidable. Domestic load. The domestic load includes lights, fans, refrigerators, air conditioners, mixers, oven, washing machines. The domestic loads usually has a peak in the evening because people return home after work. Next one, commercial load. The commercial load includes office, hospitals, hotels, shopping complex, theaters. The commercial load generally has two peaks, one in the morning, another in the evening. Next one, industrial loads. The industrial loads are classified as three types. First one, small scale industrial load, medium scale industrial load, large scale industrial load. The small scale industrial loads, the range is 0 to 20 kilowatts. The medium scale industrial loads range is 20 to 100 kilowatt. The large scale industrial loads above 100 kilowatt. The industrial loads operate for longer duration, remain fairly constant throughout the day, play a major role in the deciding base load generation. Next one, agricultural load. The agricultural load is mainly due to water pumping for irrigation, water driven by electrical supply. The load is seasonal, depending on rainfall and crop pattern. Mostly used during night or off-peak hours in many states. Next one, other loads. The other loads includes street lighting, traction. Traction means railway, metro. Next one, government and municipal loads. These loads has special operating characteristics and add to system complexity. Next topic, basics of load curve. The load curve is defined as the graphical representation of load variation with respect to time. The types of load curves. First one, daily load curve, weekly load curve, monthly load curve, yearly load curve. Among these, daily load curve is most commonly used. Importance of daily load curves. The daily load curves helps to know how load varies during different hours. Calculate units generated per day. Identify the maximum demand. Determine the average load. Mathematically, the units generated per day equal to area under the daily load curve. Average load. The average load is the ratio of area under the load curve into the 24 hours. Next one is load curve. The load curves are useful in selecting the size and the number of generators, planning operational schedules, improving the efficiency and reliability of power stations. These load curves are essential for power system planning. The importance of power system terms. Some important terms are connected load. The connected load is the sum of rating of all connected equipments. Maximum demand. The maximum demand is the highest demand during a given period. Next one, demand factor. Demand factor is the ratio of maximum demand into the connected load. The demand factor is always less than 1. Next one is load factor. The load factor is the ratio of average load into the maximum demand. The maximum demand is a daily, monthly or yearly load curve. Higher load factor means better utilization of equipment, lower cost per unit generator. Hence, utilize always aim to increase load factor. Next one is diversity factor. The diversity factor is the ratio of sum of individual maximum demands into the maximum demand on the power station. The demand diversity factor value is greater than 1. The higher diversity factor is the reduced generation cost, improves system efficiency. Next one is plant capacity factor and plant use factor. The plant capacity factor is the ratio of actual energy produced to maximum possible energy. Next one, plant use factor. The plant use factor is the ratio of kilowatt hour generated to the plant capacity into operating hours. These factors indicate how efficiently a power plant is utilized. Next one, numerical problems on load curve. First one, load curve is the time and load. Time is the x-axis and the load is the y-axis. The time duration is 0 to 6, 6 to 10, 10 to 12, 12 to 16 and 16 to 20 and 20 to 24. The load is 20, 25, 30, 25, 35, 20. Calculate the load curve, maximum demand, units generated per day, average load and load factor. In this slide, the numerical problems are given to draw the first one, load curve. Load curve is the graph between the time and load. Next one is maximum demand. Maximum demand is the greatest value of the load. Maximum value is the load is the 35 upon 35 megawatt. Next one is units generated per day. Units generated per day is the calculate the duration and load. Average load means units generated per day divided by hours in a day. Load factor is the average load divided by maximum demand. The problem helps to practical understanding of theoretical concepts. To conclude, system load variation is a key factor in power system operation. Load curve helps in planning, scheduling, and economic operation. Understanding load factor and diversity factor helps reduce cost. These concepts form the foundation for advanced control techniques. Thank you.